Look at this picture. What do you see? A grid of squares? Perfect. Now look again at the white space in the street crossing. Did you notice the small grayish dot between the black boxes? They are not part of the drawing. They were put there by your brain, and that's called an optical illusion. Welcome back to ThoughtCtrl, and today we are going to talk about optical illusion. What they are, why do they happen, and what is it that exactly happen in our brains that makes a still image move? How much of what we are seeing is actually there? But before that, I would like to ask you all to subscribe. Most of you are not subscribed. So if you like our content, click on that button now. This image is known as the Hermann grid. It is one of the most classic examples of an optical illusion, meaning that it tricks your mind into seeing something that is not actually there. The Hermann grid was first discovered by a physiologist named Ludimar Hermann in 1870. When you look at the grid, the white dot and the center of each corridor seem to shift between white and grey colors. But as soon as you focus your attention on a specific dot, it becomes obvious that it is in fact white. But as soon as you change the focus again, you get the picture, which is ironic because your brain definitely doesn't get this picture. This is just one of the countless examples of illusion that can make our mind go cuckoo. Look at the dots in the center of this image. Which one is bigger? Yeah. Don't try to be smart with me. You said they are the same size only because you are expecting to be wrong. What do you really see though? The one on the left seems smaller because your mind is somehow using the other dots to make a comparison. Now, check out this spiral. Hey, wait a minute. That's not a spiral. Those are just circles. Just because the boxes are tilted. Oh brain, why so foolish? Optical illusions can be fun. It's an old lady. It's a young woman. Old lady, young woman. Both? None? What the
Sir, below 16.
Oh, I think it's old lady.
देखा आपने लापरवाही का नतीजा है.
Some of them, like devil's tuning fork, have been around for a long time, while new one keeps coming every day. There are even annual contests. Throughout history, curious minds have questioned why our eyes are so easily fooled by these simple drawings. Even Aristotle noted that when you looked at a waterfall and then shift your gaze to static rocks nearby, it appears as though rocks were moving in the opposite direction than the waterfall. Yes, even nature is in on this facade. But we don't study them because they are fun. We study them because they help us know the difference between our perception and reality. How much of what we are seeing is actually there. Illusions deceive us for various reasons. Nearby objects can influence how you see things in focus. Messing with perspective can change your perception of an object. Sometimes illusion works just because our eyes are being deceived. But let's not just blame our window to the world. The brain is equally guilty, if not more. It can sometimes be too quick to assume about how things should be instead of how things actually are. Right from 19th century, we have been trying to learn more about reality and perception and what it tells us about our brain. And like most things we don't fully understand about why certain illusions occur, we do know though that it's mostly the brain, not the eyes. But how does the brain converts a 2D piece of paper into a 3D image? Well, it's complicated.
Please, I don't have any time for any gossip.
Not that complicated. There is a stepwise process in the way in which the brain analyzes what the eye sees. Different neurons and nerve cells are responsible for different details produced in the retinal image. But we only know what parts deal with what process. We know which part deals with colors, which part deals with form, motion, texture, etc. We have no idea how they all come together to produce the final image. Nonetheless, by using MRI scan to analyze what happens in our brain while we are looking at illusions, we have learned that neurons can actually compete with one another to influence the message your brain gets. Take the water for illusion. It seems tracking the flow of water wears out certain neurons in the brain as they adapt to the motion. Then, as you shift your focus to the rocks, other competing neurons overcompensate, causing the illusion of movements in other direction. Some researchers highlight that at least some illusions are the result of our brain constantly trying to predict the future. Our brain is constantly calculating what is going to be to compensate for the fact that there is a slight delay between when a thing happens and when we finally perceive it. The light has to travel to the eyes to be converted into signals that travel through different neurons in the brain in order to finally be processed into one image. That takes around 13 milliseconds, 60,000 times faster than we process text. So wrong calculations are the basis of this hypothesis. Another theory tries to explain apparent motion illusions, such as there is snake illusions where objects appear to be moving while the image is still. This also happens in the real world when we are in fast-moving objects like a train, for example. Scientists think that the small rapid movements our eyes make, also known as saccade, that normally get smoothed out by the brain are to be blamed here. But why doesn't the smooth function not work for only these specific images? Experts say that these images are sending so many pieces of information to our retina at once that our visual cortex get confused. But then shouldn't it stop once the brain has compiled enough data to be comfortable with the image? Yes, but with every saccade, the retinal image is refreshed, and this overwhelms the visual cortex again with a new scene. If you stop the eye movement, however, the brain adapts and the apparent motion stops. We have observed in the many illusions that once we seen the trick, it's nearly impossible to unsee it. What is seen cannot be unseen, and this cannot unsee feeling is the perfect evidence of the brain doing more than just translating what our eyes see. I think it's clear by now that different illusions work different ways, and some theories don't always hold up. In short, we are still confused about why our brain are so confused. Even the explanation for the Hermann grid, an illusion which is more than 100 years old, has been disputed, since it cannot account for the fact that effect changes when the grid has curved lines instead of straight ones. What is even more surprising is that optical illusions can be influenced by not just the brain and the eyes, but even by the things like cultural factors. In a study involving the Muller-Lyer illusion, most European South Africans perceived the lines to be of different lengths, but tribesmen from South Africa correctly noted that they were the same lengths.
Oh my god! Wow!
Again, some scientists have hypothesized that because people in Western societies are more used to seeing straight lines and geometric shapes, their brain are more prone to draw these conclusions when exposed to the illusion that are built upon geometric trickery. But, and there is always a but, when test computers designed to mimic the brain's activities were given the same illusion, they were also fooled. So just like most things, it's still an open-ended question. By the way, you may be surprised to know that optical illusions fulfill significant medical treatment purposes. Phantom limb pain is the sensation of a pain in a body part that has been amputated and no longer exists. While doctors have tried to treat this phantom pain with medicine, physical therapy, and even surgery, some of the most successful treatments have been with what is essentially an optical illusion. For this brain trickery to work, doctors have patients place their existing limb. For example, their right arm on the reflecting side of a mirror, and their brain is fooled into believing that the reflection of their existing arm is actually their amputated left arm. While the patient understands this is not to be true, the brain apparently does not. The pain often disappears after multiple sessions of playing with this mirror treatment. Fun fact, as much as this optical illusion has helped amputees, illusions may also have been responsible for causing one of the greatest disasters in the history: the sinking of the Titanic. Yes, the sinking of the Titanic.
No! God, please, no! No!
The atmospheric conditions on the evening that ship sank were ripe for super refraction on the extreme bending of the light. This light bending may have caused the iceberg with which the ship collided to visually disappear from the sight. Not only that, but after the collision, the Titanic itself may have the victim of this light bending, making it hidden from the sight of nearby ship the Californian, which should have been able to come to its rescue. Did not see that coming? Did you? Neither did they. All of this research points to one thing: our visual system remains too limited to tackle all of the information our eyes take in, and so our mind takes shortcuts like betting for the best horse in a race. Our brain constantly chooses the most likely interpretation of what we see. Seeing then is certainly not always believing. Thanks for watching this video. If you have any feedback, please let us know in the comment section below, and do not forget to share and subscribe. Bye bye, tata, hasta la vista. Of general relativity.